We're going to talk about solving rational equations. This is it. See this? That's all we have is a couple examples. Okay? This one, and then I'm trying to look up another one because I don't think I quite covered the whole picture in this one problem. So copy this down and I'll show you how we're going to solve this. Alright, now, this example, that's the reason I'm going to do two, even though I don't have two written here, is because this example is the easiest one to deal with. Because the fact of the matter is, I just have a fraction equal to a fraction, and what rules do we use to solve when we have fractions equal to fractions?
You need the same denominator.
No? What is that called when I have a fraction equal to a fraction? It's louder? I think I heard it. Proportion. It's called proportion. How do you solve proportions? Cross multiply. You actually said it yesterday when you didn't mean it, right? So we're going to cross multiply. Whoa, not like that, we're not. Let's get a marker off. So it's 1 times x minus 9 and 6x times x minus 3. So make sure, though, when you do this, you put in parentheses. You have binomials going on. You need to multiply by other monomials or binomials. You need to use parentheses. And 1 times x minus 9. I'm going to write x squared, sorry. I'm going to write it that way, but the reality is because it's a 1, x squared minus 9 is all I really needed. So on this side, 6x times x is 6x squared minus 6x times 3 is 18x equals x squared minus 9. Remember how to solve quadratics?
Can we do
Yeah. Can you say that in words?
Yeah, move that, John.
She's saying, can I just move this over here? And that's exactly what we do. So 6x squared minus x squared is 5x squared. And there's no x's over there, so minus 18x. And then the minus 9, I move that over, and that becomes plus 9 equal to 0, right? So in other words, we solve it by setting it equal to 0. Now, how do we solve quadratics? Well, we can graph, we can factor, we can use quadratic formula, right?
Is that the opposite of square?
What's that?
Nothing.
We can use square roots if we have something squared.
Oh,
You
no,
know, if
that's
I
not
had
that's not-
this, if I had a perfect square, x plus 2 squared, then we could square root both sides, right? But that doesn't work in this situation.
No, I meant the quadratic, like I was saying.
Oh. You were reading it to me. I
Yeah.
got you. The opposite of b plus or minus square root of b squared minus 4ac all over 2a, right? Quadratic formula. To be honest, that's how I would solve this one. And so b is negative 18, so the opposite of negative 18 is 18 plus or minus square root of negative 18 squared minus 4 times 5 times 9 over 2 times 5. Some of you probably are really good at this and you're solving as you're going. Oh, good, I do have a second example. I was going to find one if I didn't, because we needed to throw that in there. And so, now if we simplify, is 18 squared 324?
Yes.
Minus 4590, 180?
Yeah.
And 10? plus or minus square root of 324 minus 180. 136, no, 130, 144?
Yep.
Sorry. And that's nice, 18 plus or minus 12, right? Over 10? So that's 18 plus 12 over 10, which is 30 over 10, which is 3, or it's 18 minus 12, I don't know why I wrote an X there. Which is 6 over 10, which is 3/5. Okay. Just, sorry, my pause, I'm contemplating whether I have to worry about, remember those solutions that don't work? What are they called? Starts with an E? Extraneous. They are strenuous to find, but extraneous. Okay? Extraneous. So the only way to check it would be to plug them back in. And let's do that. If we put 3 in there, what's 1 over 3 minus 3? What is it? Nothing, because
You can't divide anything.
can't divide by 0, so 3 doesn't work, does it? Okay, so let's try 3/5. Now on this side I get 6 times 3/5 over 3/5 squared minus 9. Do you agree that 3 is the same as 15/5?
Yes.
Okay? The reason I ask that is because I have a fraction minus a whole number here, so I'm going to call this 15/5. And so that's 1 over negative 12/5, right? It's kind of hard to realize this sometimes, but when you have 1 over, well, let me ask it this way. If I have 1 over 6, what is that compared to 6?
1.
1 over 6 is the what compared to the 6?
1 out of 6. There's 1 part of 6.
No, you're not understanding what I'm not asking it well enough. I'm not blaming you. The numbers 6 and 1/6 share what relationship? What are they to each other?
Reciprocal.
They're reciprocals. Okay? So when you see 1 over 6, you realize, oh, well, that's the reciprocal of 6. Well, if I have 1 over negative 12/5, that means I have the reciprocal of 12/5. No, I'd have to flip it over. So 5/12. Okay? Dividing by 12/5 same as multiplying by 5/12. So if I have 1 over, I can just flip that over. Put it at the top, flip it over. Okay? Alright, so then, let's go on to the next one. This is 6 over 1. So that's 18/5, right? And then what's 3/5 squared? What's 3 squared?
9.
What's 5 squared?
25.
So what's 3/5 squared? 9/25. Minus 9. I guess I'm not sure. 9 times 25, right? So 4 times 25 would be 100. It'd be
Four.
it'd be 9/4. No. Just tell me, what's 9 times?
225.
Oh, yeah. I was going about that the wrong way to do it in my head. And so what's 9/25 minus 225 25?
Negative 216.
Negative 216, okay. So 18/15 over, oh, okay, sorry. 18/15 over negative 216 over 25. Sorry, I didn't leave myself enough room here. Okay, so negative 5/12 equals 18/15 times, if I flip that over, it's negative 25 over 216. You agree that 5 goes into each of those? How many times does 5 go to 15? How many times does 5 go to 25? Okay. If I'm gonna get 12 on the bottom, what do I have to get at when I simplify my 216? Alyssa,
Hmm?
did you say it? Easton? 4. If I'm gonna get 12 when I multiply these two on the bottom, then when I cancel this, I gotta get 4, because 3 times 4 is 12. So I'm saying then, what goes into 216 4 times?
54.
I'm guessing it better be 18, since on top I better get a 5 times 1, right? So check it. Does it? Matt, what's your question?
What was that number on the right fraction numerator?
Up here?
No.
Down?
Yeah, that right there.
25. I took this fraction, remember, instead of dividing, I'm going to flip it over and multiply.
Mr. Mitchell, are you saying that 18 goes into
216 4 times?
That's not.
It doesn't?
No, it goes in there 12 times.
It's negative 5. If you plug in some background.
What'd you say?
I plugged into this by problem, I got the answer. And it did match up.
You just typed it all in, let your calculator do it?
Yeah.
Does 216 go away? So fine.
Well, I agree that 18 goes into 216 more than 10 times, because 10 times is 18 and 180. Where did I make a mistake? Yeah.
It should be 18 over, no, 18 over 5.
That's a full page of order.
Oh, I made my mistake early in life.
18/5.
Good job, Betty.
Okay.
Way up here.
Mhm.
6 over 1 times 3 over 5 is 18 over 5, not 15.
Whoa, that's way up there.
Yep, sorry.
I put 18 over 5, not 18 over 15.
Yeah, I put 18 over 5.
The whole time I did 18 over 5
I
until the last problem.
Well, that's good.
Then that 5 becomes a 1. There
Yeah.
we go.
Good catch, Benny. So that was a 1 now, because I canceled, no, it's still a 5. I'm canceling that 5 and getting a 1 when I cancel the 5 here and get a 5. And so I get 12. 1 times 12 is 12, 5 times 1 is 5. So it does check out. I just wrote the wrong number down. Okay? So our answer that works is 3/5. It's Too bad 3 wasn't the one that worked, that'd been a lot easier to figure.
Well,
I forget that you can use your calculator and just put that fraction in and let it test. You can actually write it out. You can write it out. You can go 1 over 3/5 minus 3. Put myself in a bind again. Equals 6 times 3/5 divide 3/5 squared minus 9. As long as you type it in with the fractions and the squares, the parentheses, and do everything you're supposed to in your calculator, you come over here, your calculator will say true. Okay? Or it will say false. Alright? So you can actually do that, and
so that makes our lives a whole lot easier.
yeah. I forget that. I mean, I'm not used to having these calculators. Alright, so it's not that I wanted to spend 10 minutes doing this and then leaving and putting the wrong number down. I just forget that the calculators do that. Alright? So let's move on to the next one because it's a little different. In this case, it's not just a proportion, is it? So I can't just do cross products. Okay? They're b's. 1 over b plus 1 plus 1 over b minus 1 equals 2 over b squared minus 1. Okay? You don't have to copy this down. 1/2 plus x over 3 equals 7 over 6. Alright? You don't have to copy this down. Just reminding you in simple numbers. What is the common denominator in all 3 fractions? 6. Because we need a 2, we need a 3, and over here we need a 2 and 3. Right? If I broke it down in factors. So I need a 6. So we can multiply everything by 6. When I multiply the first one by 6, the 2 cancels, leaving me with 3 times 1, which is 3. When I multiply the second one by 6, the 3 cancels, leaving me with 2 times x, which is 2x. When I multiply the third one by 6, the whole 6 cancels, leaving me with 7. And so we took this ugly-looking equation with all these fractions, multiply it by the common denominator, and we get a simple-looking equation. Our answer may, oh, it does actually work out. X is 2. Okay? What's wrong?
I don't know, just the way that you did that just confused me. Why did you put the numbers under it and why did they all cancel?
I was just showing what factors was in these numbers.
Okay.
The factors of 2 were 2, factors of 3 was 3, factors of 6, 2 and 3. Okay, that's all I meant to show by that. Okay? Anyway, that's the process we're going to use here. So this factor is b plus 1, this factor is b minus 1. How does this factor? It would be, wouldn't it? Which is b plus 1 and b minus 1. Very good. All right, so what's my common denominator going to be?
1.
What is it?
Negative 1.
No,
I don't
common denominator has to have all the factors in it that are needed. You can't just take one.
Plus 1 and
B plus 1 and b minus 1. Okay? Remember yesterday we were adding, we had to have common denominator? Today we're not adding, so what we're going to do is multiply. Well, that's not what I want to do. Just erase that. So it's not in the way. So all we're going to do now is multiply everything by that denominator. B plus 1, B minus 1. Okay? Just just like we did with the 6. We're going to multiply everything by that. So when I go to this first fraction, what is going to cancel? B plus 1, leaving me with B minus 1 times 1, which is B minus 1. Plus, when I multiply the second fraction, what's going to cancel? B minus 1, leaving me with B plus 1 times 1, which is B plus 1. Equals, what's going to cancel in the last one? Yeah, all of it. B plus 1, B minus 1, leaving me with a 2, the number that's on top. And remember, if everything did cancel, it would be a 1, right? If you divide 6 by 6, you get 1, right? Okay, so now if I solve this, what's B plus B? 2B. What's negative 1 plus 1? So I get 2B equals 2, so B equals 1. So we got B equals 1. Does that work?
1 over 1.
Still hear some yeps?
Will the B's?
What's B minus 1 if B is 1?
0.
And divide by 0? No. It doesn't work, does it? We only got one answer and it didn't work. Because B can't be 1. 1 minus 1 is 0, and I'd be divided by 0. It's undefined, remember? So what do we write? We only got one answer, it didn't work, so what do we write? Okay, what's another way of saying impossible?
Undefined. Not possible. No solution.
Not possible solution.
No solution is a good way of saying that. Okay? Alright. So you do have to check your solutions when you're done to make sure that they work. Because as we saw here, they don't always. And sometimes we only get one that doesn't work. Alright? So, I'm going to pause this while I recheck all of these, see if they're all necessary. So, quiet please. We're crossing off 2 and 16, but do 4, 12, 21, 40, 46, 48, and 52. That'll be a fair sample of what you need to practice to make sure you're ready for any test question on those. Okay?